Welcome back. So now I'm going to take a new topic which is on electric field. Now we are going to study about electric field and electrical intensity, how to find out electrical intensity due to a point charge, okay, and electric field lines. Okay. Now the topic is electric field intensity. To know about electric field, so it is a region or a space around a charge where any other charge can experience a force of attraction or repulsion. So let us see. Suppose you have a charge Q here, a charge Q. This is what we call as source charge. Source means we have to find the electric field due to this charge. Okay, so these charge will experience a force of attraction or repulsion on another charge. If the charge is placed here, if another charge which is called as test charge, if a test charge is placed here, then it will experience a force of attraction or repulsion. If I take this test charge somewhere here, then you will find that the force of attraction or repulsion is reduced. Why? Because it is moving far away from this source charge. And if it is taken to very far extent, the force will decrease. And if I keep here, the force is more. Okay, so that is why there is a region or a space around this charge. Space around this charge where electrostatic force of attraction or repulsion can be experienced by any other charge. So that region or space is what we call as electric field. So look at this. So electric field due to a charge is the space or region around a charge at which electrostatic force means attraction or repulsion, can be experienced by any other charge. That is what we call as electric field. Okay, electrostatic field or electric field. Okay, so that means a charge Q is here, so there must be a region around which any other charge can experience a force on it. Okay, if it experiences a force, that means this is within the region of electric field. Actually, it is a very long, it goes to up to infinity, but it is a very weak force. Okay, so field means within the region where electrostatic force can be experienced on any other charge. This is the definition of electric field. Now let us look at the next topic, that is the electric field intensity. Electric field intensity or the strength of electric field. Okay, strength of electric field or electrical intensity denoted by E vector. So what is electric field intensity? So if I suppose take a charge as considered in the last time, suppose this is a charge which is called as a source charge. So if a test charge is brought here, so that means we have to measure the electric field intensity at this point. So to measure the electric field intensity at this point, what we are going to do is we have to find out the force experienced on this test charge. How much force per unit test charge? That is what we call as electric field intensity. If the force experienced is more, that means electric field intensity is more. If the force experienced on this particular charge is less, that means electric field is weak in that region. So that is why electric field intensity at a point or due to a charge. So electric field intensity due to a charge in an electric field may be defined as the electrostatic force experienced on a vanishingly small unit positive test charge placed at that point. So this is a definition of electric field intensity. It is a vector quantity. It is a vector quantity and denoted by E vector and written as E vector equals to, as it is vanishingly small, limit of Q naught, that is the test charge tends to 0, that means the force experienced per unit test charge. So this is our definition, and this is the formula of finding the electric field intensity. So electric field equals to limiting of Q naught tends to 0 F by Q naught. This is how we can measure the electric field intensity. Then what is the SI unit? SI unit of electric field intensity is force measured in Newton, and Q naught measured in Coulomb. So that is Newton per Coulomb. Newton per Coulomb is the SI unit of what? SI unit of electric field. Now I will take up there is another topic. There is expression for electric field intensity due to a point charge. So how to find the electric field intensity at any point due to a point charge. Okay, for this let us consider a source charge Q here. So consider a source charge Q. Okay, source charge Q. Now let us consider a unit positive test charge Q naught at this point. Now which is at a distance of R from this. R from the source charge. And let this is the position A and this is the position P, which is at a distance R from the source charge. So we have to find the electric field intensity point. Okay, to find it, before finding the electric field intensity, we have to find the force between these two first. Okay, so that is why if it is R unit vector, let us consider R unit vector, it is moving from A to P. Okay, suppose if it is plus charge and if it is plus charge, then the electric field will be in this direction. Let us see what should be the direction of the force. So it will experience a force F is equal to Q K, constant of proportionality, that is K Q naught by what? R square and the R unit vector. So this is the force experienced on this particular test charge. Okay, so now consider a source charge plus Q at point A. Let P be any point, let Q naught be a vanishingly small unit positive test charge. Let Q naught be a vanishingly small unit positive test charge placed at point P. Let's at point P, which is at a distance how much? R from the point A. Okay, or from the charge plus Q. Okay, now force on Q naught due to plus Q. Force on Q naught due to plus Q is given by F vector is equal to K constant Q naught divided by the distance square and the R unit vector, the vector alone. Consequently, if it is positive, it will be away. Okay, so if this R unit vector, I am mentioning here R unit vector from A to P. Okay, unit vector along A to P in this case. So that is why this is the value of the electrostatic force on this particular test charge Q naught. Okay, now then by definition of electric field intensity, If we remember the definition of electric field intensity, it says it is defined as the force experienced per unit Brownian mole. So limiting of Q naught tends to 0 F by Q naught. I hope this is the definition of electric field intensity. So this further implies E vector is equal to limit of Q naught tends to 0. F, I will put the value of F, K, Q naught by R square, R unit vector divided by Q naught. This is the value of F and this is Q naught. So Q naught cancel out. So this further can be written as E unit vector is equal to limit. Now Q naught cancel out. So it is only K Q by R square, R unit vector. So the direction of the electric field is along the direction of the force on this Q naught charge. If it is plus Q charge and it is since it is plus Q, so the direction of force is along this direction. So obviously the direction of electric field is also along the same direction of the force. Suppose if I take a negative charge minus Q here, then Q naught which is positive, so the force will be along this direction. So the direction of electric field also in the reverse direction, that means towards a negative charge. Okay, so from here we came to know that electric field is always away from the positive charge and electric field is always towards a negative charge. Okay, so this is the expression for electric field due to a point charge, or we can say electric field magnitude is equal to KQ by R square. Also we can write 1 by 4 pi epsilon naught, which is the value of K Q by R square. Also we can write the electric field intensity in magnitude as the value is 9 into 10 power 9. The value of 1 by 4 pi epsilon naught Q by R square. These are the different forms of magnitude of electric field intensity due to a point charge. Okay, so this is electric field intensity. So we can now plot a diagram or graph between the electric field E. This is E and this is R. Distance from the electric field. So we came to know that E is inversely proportional to R square. So the graph of E versus R will be somewhat like this, a curved line. Okay, curved line like this. So it is depending on E and R curve. Okay, so this is a curve of electric field with respect to distance R from the charge. Okay.